Okay, in the case of grams to atoms, we're going to have a process that involves two steps, and two steps are two conversion factors. So remember what I told you about the keywords in a word problem. So let's read this problem. It says, how many atoms of aluminum are in 200 grams of aluminum? In this case, the situation is, sorry, this is the last example. Wait, now this is it. In this process, it says, what is the mass in grams of 1.2 times 10 to the 8 atoms of copper? Okay, so remember what I told you. We're going to have keywords in the questions, okay? And those keywords are going to tell you what to use. Do you remember the keyword grams? When we have grams, Kelly? Uh-huh. Yes, we're going to use the formula that is Avogadro's number. But remember I said, when we have a word like grams, what do we need to use as a conversion factor? Molar mass or Avogadro's? Uh-huh. So the word grams tells you that you need to use molar mass. Now, we also have another word, another keyword that is atoms, okay? Exactly. So, in this kind of problems, you see that we have the two keywords together. With atoms, you know that we have to use Avogadro's. So, that means that these kind of problems need to have two steps, okay? But the idea remains, okay? The idea in this kind of problems is going to remain. So take a look. We're going to begin with the given. The given are 1.2 times 10 to the 8 power atoms of copper Cu, okay? So, what do we need to do? First, I'm going to include in my procedure, I'm going to include the number 1 in the bottom. In this way, I'm going to be able to make the conversion, okay? Now, because my atoms are in the top, what conversion I need to use? Avogadro's or molar mass? We need to use Avogadro's, okay? So, we're going to start by writing atoms of Cu in the bottom. And what number goes next to atoms? 6.022 times 10 to the 23 atoms of copper in 1 mole of copper. With this, you can see that we should be able to eliminate atoms with atoms and copper with copper. Now, if I solve this, it's gonna give me moles of copper, but the problem is not asking me moles. The problem is asking me grams, okay? So, let's solve the first step let's solve this part, okay? Let's solve this part, then we continue. How much is this? 1.2. Remember how you do it in the calculator. You do it like 1.2 exp 8. Ay. $1.99 times 10 to the negative 16 power. And we're going to write the units that we didn't cancel, that are the moles of Cu, the moles of copper. But the problem is not asking me moles of copper. The problem is asking me grams of copper. So then I need to convert. From these moles, I need to convert to grams. So how do I do this conversion? With the molar mass, okay? So again, I'm going to place an invisible one in the bottom, but now I'm going to be using the molar mass of copper. What is the molar mass of copper? Okay, those 63, where do I get them from? Remember, in here, from mole to grams, I'm going to use the molar mass, and the molar mass is in the periodic table. Okay, so because I have moles in the top, I need to write my moles of Cu in the bottom. What number goes next to mole? 1, always 1. Remember this. Next to the moles, you're always going to write the number 1. And above, you're going to write the atomic mass, grams of copper. With this, you are able to get rid of moles of Cu with moles of Cu. How much is this? $1.26 grams of copper. Okay, now from this, we say that it is over. Now remember, there are 2 steps. How do you recognize there are 2 steps? Because of the keywords, okay? Because of the keywords. The problem here gives me, is asking me for grams, okay? This is the unknown, the mass in grams, and the known, the given are atoms, okay? So we need to analyze the problem in that way. Grams with molar mass, atoms with Avogadro's number. And we always want to put them in the way that we can cancel. Now, this is one way to do it, or you can do it in a single phase procedure. Let's try one more example. Okay, let's try one more example. Now let's see. I don't know what I did. Okay. I don't know what's going on with. Can you see my screen? Okay. Thank you. Bueno, let's continue. Now, let's do one more problem, okay? How many grams of chlorine are in 2.54 times 10 to the 23 electrons of chlorine? So here I analyzed the given and the unknown. My given are electrons of chlorine. And because I have the keyword electrons, I know that I have to use Avogadro's number. My other keyword is they're asking me for how many grams of chlorine. Grams of chlorine is my unknown. And because the word gram is implicit in the question, then I know that I have to use molar mass. So we start with the given. So we start with the given and we say 2.54 times 10 to the 23 electrons of chlorine. And I will put 1 in the bottom. Okay? What conversion factor I have to use? Avogadro's or molar mass? Avogadro's. So electrons are going to be in the bottom. The number that is going to be next to the keyword is going to be my Avogadro's number, 6.022. 6.022 times 10 to the 23 electrons of chlorine, and above only 1 mole of chlorine. With this, I notice that I can get rid of electrons with electrons, chlorine with chlorine. Now, take a look to what I'm going to do now for you to see that we can do this in one single procedure. Okay? Now, take a look to this. I have moles of chlorine. The procedure that I just did here is from electrons to moles. Now, what I want to do is from moles to grams. If I want to do from moles to grams, I need to use the molar mass as a conversion factor. So, I'm going to write the molar mass here in the way that I can cancel my numbers of moles. Remember, moles of chlorine needs to be written in the bottom. Why? Because you want to cancel the moles of chlorine. What is the molar mass of chlorine? In 1 mole of chlorine, you have 35.45 grams of chlorine. With this, you see that you can get rid of moles with moles, chlorine with chlorine, leaving you with only grams of chlorine. And remember, you can do all this in your calculator. You multiply everything in the top and you divide everything in the bottom. How much did you get? 14.95. Yeah, it makes sense. 14.95. These are gonna be grams of chlorine. So as you can see, we can do the process in 2 steps, like the longer process, or we can do in one single step. But also in the 2 ways you have to use the 2 conversion factors. Only that the first one is a little bit longer, but it's the same. It's 2 conversions here, but also 2 conversions in the bottom. The procedure is the same. If you feel more comfortable by doing it in the first way, don't worry, you are free to do it. If you feel more comfortable to do it in the second way, you are free to do it. From these 2 examples, do you have a doubt? What method do you prefer, the first one or the second one? Maybe you can write it in the chat for me to decide what method we're going to be using. Okay, the second. Okay. Okay. Bueno, the second one it is. Okay, the second one is going to be because all of you told me the second one. Just let's do one more example to get ready for the next one. Okay, let's do one more example to get ready for the next one. So let's see. How many grams of iron are in 6.75 times 10 to the 24 molecules of iron? Okay, let's work with this one. How many grams of iron are in 6.75 times 10 to the 24 molecules of iron? So, as I told you, we analyze the keywords. I have grams and I have molecules. So, I know that I have to use molar mass as a conversion factor, and for molecules, I know that I have to use Avogadros. So with this, I recognize that I have to do a two-step procedure. So I'm going to start with the given. My given are the 6.75 molecules of iron. And my unknown are grams of iron. Okay, so we start with the given and we say 6.75 times 10 to the 24 molecules of iron. And I place it over 1. Okay. Molecules in the top, I need to write molecules in the bottom. So I can get rid of them. How many molecules? The Avogadro's number. The Avogadro's number, okay? So this is gonna be 6.022 times 10 to the 23. And above, I'm gonna have just 1 mole. Just remember this. Every time you use a conversion factor, molar mass or Avogadro is always gonna be in 1 mole of the same substance. We get rid of molecules with molecules and iron with iron, and then I need to convert from moles to grams. In what part I'm gonna need to write my moles, up or down? Down. So in 1 mole of iron, how many grams I have in 1 mole of iron? 55.847 grams of iron. I get rid of moles with moles and iron with iron, and in the end I have how many? Sorry? 625.98 grams of iron. Do you have a doubt on this procedure? Okay. If there are no doubts, then I continue with the next one, the next type of conversion. It says grams to atoms, which is also a two-step process. How many atoms of aluminum are in 200 grams of aluminum? The analysis of the question is very similar. Well, actually, it's the same analysis. Okay? I see the word atoms, and I know that is a keyword for Avogadro's conversion factor. And I see the word, not the word, but I see the unit gram, the abbreviation of grams. So I know that for here, I'm going to use molar mass. So because I need to use the two of them, I need to use Avogadro's, and molar mass is going to be a two-step process. So I'm going to start with my given. My given are 200 grams of aluminum, and my unknown are how many atoms of aluminum. I know. Okay. Okay, let's begin. So we start with the given, 200 grams of aluminum, and I'm gonna place it over 1. So if I have grams here, what conversion factor I have to use first? Avogadro's or molar mass? Molar mass, that is correct. How many grams of aluminum are in 1 mole of aluminum? 26.981. That is correct. In here you notice that we can get rid of grams with grams and aluminum with aluminum. And we continue. Okay, now I have to convert from moles to atoms according to what the problem is asking me. Okay, because they gave me grams, so I begin from grams to moles, and then I can continue from mole to atoms. So in what place I'm going to write moles of aluminum, up or down? 1 mole of aluminum. How many atoms do you find in 1 mole of aluminum? The Avogadro's number. If you don't want to say, just say Avogadro's number. I will understand. So it's going to be 6.022 times 10 to the 23. Because the problem is asking me atoms, I'm going to write atoms of aluminum. And here you notice that we can get rid of moles with moles and aluminum with aluminum. So how much is this? 4.46 to the 24 power. And we write the units. We don't forget to write the units as atoms of aluminum. Do you like this topic? More or less? Okay. It's a little bit more complex, but in the end, they are just conversions. They are just conversions, okay? I'm gonna try one more example. Let's see, I have a message. Okay. Yeah, it's easy when you understand. When you understand a topic, the topic becomes beautiful. Now, let's see. Let's try with another example. How many electrons of sodium are in 95 grams of sodium. So I analyze my question. I see electrons and I think about Avogadro's number. I see grams and I think about molar mass. Because we're talking about sodium, it's going to be the molar mass of sodium. So we start with the given. As I told you, the given is the number, the unit, and the substance. So we say 95 grams of sodium and we place it over 1. What number I have to write in the bottom? What is the molar mass of sodium? 22.989. Did you find sodium in the periodic table? It is in the position 11. Okay, so you can go and see the numbers. 22.989 grams of sodium that are in 1 mole of sodium. You cancel grams with grams, sodium with sodium. What comes after? I need to find how many electrons. How many electrons? They're asking me for electrons. Okay? I need to use Avogadro's number. In what part I'm going to write Avogadro's? Up or down? Up. The number comes up. Okay? 6.022 times 10 to the 23. And they're asking me for electrons. So these are going to be electrons of sodium. And these are over 1 mole of sodium. So in here you cancel moles with moles and sodium with sodium. So how many electrons are these? 2.49 times 10 to the 24 power. And what units are these? Electrons of sodium, that is correct. So I'm going to give you one for you to practice in this moment. In the page 16 from your booklet, page 16, try to do the first one. And once you have the answer, you write it to me in the chat. Wait a second, I'm looking for the page 16 here so I can project the exercise in case that you don't have the booklet with you in this moment. Okay. Yeah, the exercise is the exercise 11. Uh-huh. Well, that is going to depend on the units that you are working with. So for example, if I give you atoms and I ask you for grams, so because you start with atoms, you're going to start with Avogadro's number and you're going to finish with molar mass. In the case of me giving you grams and asking for atoms, because you start with grams, you're going to start with molar mass and you're going to end up with Avogadro's number. Efrain, okay, Angie, your answer is good. Efrain, maybe you forgot to write the exponent. Is 8.03 exp 23. Remember that you. Okay. Uh-huh. In the what? Yeah, in that one, you're going to start with molar mass. Okay. Gabriel, you're gonna have to send me your process to WhatsApp, okay? Gabriel, the rest, the answer should have been 143.84 grams rounded, okay? If your answer is different than that, send it to me so I can see where your mistake was.